Last week, we went over calculating the IV flow rate via dimensional analysis, the formula method, and the division factor. You will have to know those three methods for calculating the IV flow rate. IVs are usually ordered in milliliters per hour or drops per minute, and those methods we were doing the drops per minute. If the manual flow rate is what you're calculating, in other words, if it's not on an infusion pump, you're going to be calculating drops per minute, and you have to know the drop factor or drops per milliliter on the IV tubing that you're using. This week we're going to be calculating infusion and completion times, and you will also need to know international, or some call it military time, versus standard time. So first we need to be able to differentiate what is infusion time and what is completion time. The infusion time is the total time that is required for the IV solution to infuse completely. Your completion time is going to be the actual clock hour or minutes when the infusion bag or whatever you've got hanging empties or finishes. Now, there are several reasons why we would need to calculate IV times. First of all, you need to have your next bag ready. You don't want to, your current bag to empty and you not have the next one ready to hang. Also, to discontinue an IV when the infusion is complete, so you need to have an idea of when that's going to be. Also, to label the IV bag with start, progress, and completion time, which you have some exercises at the end of the chapter to do that. To monitor and adjust the infusion to keep it on schedule. And then on the next slide, it's going to be sometimes laboratory values are, labs are drawn before, during, or after a specified amount of IV solutions have infused. For example, we will draw peak and trough levels on antibiotics at times. Well, those have to be drawn at very specific times in relation to when the antibiotic has infused. The trough is usually drawn right before you give an infusion of, say, let's take for example gentamicin. The peak must be drawn 30 minutes after a 30-minute infusion has completed. So you have to know when that drug is going to be completed in order to order that lab and have it drawn at the correct time. Now, calculating the infusion time is pretty simple. You've got your, and I don't have my stylus, so this is going to be not too good of writing here. So you're going to have your total volume, that you're infusing, and you're just going to divide that by whatever your rate is in milliliters per hour. So if you had 1,000 milliliters and it was infusing at 125 cc's an hour, milliliters per hour, that would take 8 hours to infuse. Here you've got another example. Calculate the infusion time for an IV. You've got a total amount of 1,000 milliliters. It is infusing at 100 milliliters per hour. So you're going to take your 1,000 milliliters, divide it by the 100 mils per hour. That's going to take 10 hours to infuse. Now the last example comes out even, 1,000 divided by 100, 10 hours. Obviously, it doesn't always come out to even hours. Sometimes you have fractional hours. And then you have to convert the minutes by multiplying 60 minutes by that fractional hour. Here's an easy example. Let's say that we have 140 milliliters. It's infusing at 40 milliliters per hour. Oops, sorry. You divide 140 by 40, and you come up with 3.5 hours. That's how much it would take. So you take your, I'm using this as an example because it's easy to conceptualize. So your 0.5 is your fractional hour, so 0.5 times 60 equals 30 minutes, which of course we know that half an hour is 30 minutes. So that's easy to kind of figure in your head, but that helps you kind of see how you convert those fractional hours. So here you have another example. Calculate the infusion time for 500 milliliters. It's running at 75 milliliters an hour. You take your 500 milliliters, divide it by 75 milliliters an hour, and you come up with 6.67 hours. So you have to take your 0.67 times 60 to get your minutes. You will carry it to the 10th, and then you are going to round. So this IV would infuse in 6 hours and 40 minutes after we rounded the 40.2 to 40 minutes. Now we'll move on to calculating completion time. What we just did was calculate infusion time, or how long it was going to take to infuse an IV. Completion time is calculating the time that it's going to be totally infused. So what you're going to do is you're going to add your infusion time to the time the IV was started, and you will either use military or standard. Now most hospitals use military time, and we'll talk about that next. So what we're talking about here is the actual time, well, I keep doing that, in hours and minutes that it will complete. In real time. Most of the time, care facilities are going to use military time. This avoids a lot of confusion in terms of, is it AM or is it PM in using military time. Military time is based on a 24 hours on a day clock with no repetition of hours and numbers. Obviously on standard time, you know, 1 o'clock, well, is that 1 a.m. or is that 1 p.m.? In military time, you end up adding an hour after noon for each additional hour after 12. And so it's going to be written in 4-digit numbers. So we start with 2400 is midnight, and then 1 a.m. is 0100, and it goes around the clock like that. You can see here that when we get to 12 p.m., which is noon, that's 1200, and then we start adding the numbers, so 1 p.m. is 1300, and so on. 2 o'clock is 1400, 1500, and we keep going. 11 p.m. then is 2300, and then we get back around to 2400 and start over. So let's calculate the completion time for 500 milliliters. It's running at 75 milliliters an hour. It started at 0800 or 8 o'clock a.m. We take our 500 milliliters to get our infusion time and divide that by 75 milliliters an hour. We've already done this problem. It's going to take 6.67 hours. So 60 minutes times 0.67, that's our fractional hour, is going to be 40.2, which would be 40 minutes. So our infusion time of 6 hours and 40 minutes is going to be added to our 0800. And it's really easier if you look at it this way. 0800 plus 0640 is going to give you 1440 or 2:40 p.m. And so that would be your completion time. Now the next section in your book is labeling IV solution bags, and it's labeling it in reference to when it will be completed according to the rate that it's running at. You note that the calibrations on the IV bag are not all the same width. Why is that? Well, gravity and pressure, you can see here that this area right here is wider than, say, this area right here, up there. The reason for that is gravity and pressure of the fluid are going to force more fluid to the bottom, so the calibrations are wider at the bottom. Each 50 is calibrated, and you can see that on, like right here is pretty easy to see that each 50 is calibrated, but only the 100 milliliter calibrations are numbered. This example was to infuse 100 milliliters over 8 hours, so you would divide 100 divided by 8 would be 125 milliliters per hour, and so each at 9 a.m. is when it was started, and then you go down 125 milliliters and you mark it at 10 o'clock at 125 milliliters, and you would keep doing that. Skip this, sorry, got an extra there. Now what we just saw was a commercially prepared label that's available. You can also just use a tape as long as it's easy to write on, easy to read, and it's wide enough to contain the written times. All right, so here we have another example, and I've put a picture onto the slide here. If you've got an IV of 1,000 milliliters and it's running at a rate of 150 milliliters per hour, and it started at midnight or 2400, you're going to tape the bag with start, progress, and completion times. That's the example that I showed you before. So right here at 0, we would mark this, and my fingers are too big to do it only on the tape. That would be marked 2400. Then you would count down 150 milliliters, so that would be right here, and that would be 0100. And then you'd count down another 150, so there's 50 plus 100, so right here at 3 would be 0200. Well, you get the gist. And you would just keep marking your, you would start at the top, obviously, and you just keep marking your tape down so that you have an idea when you get to the bottom of when this would be completed. Down here you'd have your completion time. This just goes ahead with the progression of that same IV solution and IV rate, and I'm not going to mark it. If we go back to the previous slide, and we were here at 0600, then we know that it would be 0640 milliliters, and this would have been marked at 0600, and we'd have 100 milliliters left. Let's go to the next slide. And so we'd want to calculate the infusion time for the remaining 100 milliliters. We'd take the 100 milliliters, divide 150 milliliters, because that's how fast it's running per hour. It would take 0.67 hours for that 100 milliliters to infuse. we'd take that fractional hour times 60 minutes, and that would give us our 40.2. We'd round that to 40 minutes. And so if we go back to the previous slide, it would be 0640 when this total infusion would be complete. So that would be our completion time. And you can see that here on the last slide. Work these problems in your book, and we will go over this and have some sample problems tomorrow.